your mind when you hear the word mathematics? Let me guess. The first thing you might think about is numbers. Am I right? Numbers are the heart of mathematics, but mathematics is more than simply numbers. According to Stewart, numbers on their own form only a tiny part of mathematics. Today, we'll dive right in and study some mathematics from Stewart's Nature's Numbers. Since its early use, mathematics has evolved significantly with the help of some of history's most brilliant minds who have contributed their wisdom and expertise. Our understanding of various areas of math, such as numbers, has substantially expanded. Mathematics has progressed from simple counting lines on our wall and using tokens with symbols to complicated variables and problems that can explain and quantify practically everything that happens in the world.
Have you ever wondered how people used to count 1,000 years ago? Let me tell you this. Around 500,000 years ago, people used counters. Counters were tokens containing illustrations of the materials or thing they represented, wherein each counter form reflected a specific quantity of a certain commodity, which helped them to figure out how much of that commodity they had. The accountants of that time recognized the flaws of this system, which they fixed by coming up with simple solutions that eventually led to the discovery and use of counting numbers. Then people began to discover fractions, which meant a portion of a number, the concept of zero to symbolize nothing, and negative numbers to signify death. History events like this demonstrate how human ingenuity is responsible for the advancement of the number system in mathematics.
Now we'll discuss mathematical processes to help us comprehend and learn more about mathematics. First, let us define mathematical process. Mathematical process is a calculation by mathematical methods. There are quite a few interesting things about mathematics. Did you know that mathematical things do not exist in the real world and that they are abstractions? Yes, mathematical processes are abstractions. Mathematical things do not exist in the real world. Mathematics is just as much a thing as the things to which it is applied.
Another recurring theme is the thingification of processes. For example, number 2 is not thing. It is a process that occurs when two sheep or two camels are associated with symbols. Due to the fact that numbers were long ago thingified by humans, everyone now considers them to be things. To be honest, I thought of two things as well. But after studying mathematics, I realized that 2 is simply a number and an abstract concept. Mathematics creator analyzes its unsolved problems, defines them, and constructs paths through them to make more accessible to all.
However, some mathematicians are frustrated as well, with the lack of credible evidences being one of the primary sources of criticisms. These are the emotional experiences of the creative mathematicians. One is the frustration of the unsolvable nature of what should be a simple question, elation when an idea occurs, suspicion when checking for credible sources and holes in their argument, and exhilaration when the argument is proven correct, and how it resolves the complications. Its primary goal is to provide solutions, not to cause confusion or deception. Mathematics helps in improvement of certain characteristics, such as reasoning ability, creativity, abstract or spatial thinking, critical thinking, problem solving, and even good communication abilities.
Fast forward to a few years later, mathematics continued to evolve from solving minor inconveniences or situations to defining even the tiniest occurrences around us. This is when the concept of mathematical proof became increasingly relevant. The meaning of proof is easily conveyed through the ship-dock theorem, which summarizes how something is proven in mathematics and its value when it comes to statements. The ship-dock theorem shows the application of analysis and connections between factors to find evidence to support a claim or theorem.
The ship-duck theorem can be proven through simple analysis and establishing truths. One truth is that all four-letter words in the English language have at least one vowel. This can be proven by looking at the dictionary. Once we know that any four-letter English word must have at least one vowel, the next step all comes down to analysis. The word ship has a vowel in the third letter position, and the word duck has the vowel in the second letter position. To change the word ship into duck, the vowel would have more than the third letter position and the second letter position. The only way that this can be happen is if another vowel is added somewhere during the solution process.
Let's say you now have a basic understanding of mathematics. Now what about the people that contributed to the mathematics that we study today? Do you know about them? As a result of contributions of people all across the world, mathematics has considerably improved. The Greeks refined analytical methods by introducing deductive reasoning and mathematical rigor in proof. Their contributions has further expanded our understanding of mathematics.
Carl Friedrich Gauss made significant contribution on number theory, geometry, probability theory, geodesy, planetary astronomy, function theory, and potential theory, including electromagnetics. Another mathematician named Alfred North Whitehead developed the extensive abstraction theory. Bertrand Russell, known for his works on contemporary system of logic, worked together with Alfred North Whitehead. Both of them made groundbreaking contribution called Principia Mathematica.
So that ends our presentations. We hope you enjoyed our discussion and learned something. We also appreciate your time and attention. Also, let us not forget to increase our knowledge in math. Math is difficult but enjoyable, right? Mathematics is not about numbers, equations, computations, or algorithms. It is about understanding. Thank you everyone and have a great day.